Hello everyone, a very good morning and welcome to my course Basic Physics. This course is generally made for diploma degree first year first semester students. Myself Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baraipur. So you can personally meet me at college premises, ground floor, physics lab. You can also send me your doubt or your query regarding this topic that I have discussed in my given mail ID, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@jisgroup.org. Students, I have a YouTube channel. You can subscribe my YouTube channel for more videos. I have already uploaded all the videos as per your State Council syllabus, so you can go through that videos, and if you feel any doubt, feel free to contact me. Now the course pages are www.websct.org and www.webscte.co.in. The syllabus for this subject, Basic Physics, is already uploaded in the State Council website. So students, you can download the first year first semester syllabus from the university web page as I have given here. So the title of this course is Basic Physics. It is under the category of Basic Science course. It has a credit 3, 2 lecture per week and 2 practical per week. This course is generally made for diploma degree students of first year first semester. So basically the students, those are passing out from class 10 level, have to study this course for their first semester. So all department, all branches except architecture, photography, multimedia and printing technology have to study this course. So as per our college, the electrical and electronics and communication, these departmental students will going to study this basic physics course as a subject for their first year first semester. Now, the topic that I will going to discuss in today's class is application of dimensional analysis and the dimensional formula with examples. So these are basically the continuation of the last class where I have discussed about the dimensional analysis. So the today's class also under the unit 1, that is unit, dimension and measurement. So the prerequisite for this class are basic mathematics knowledge to solve the problems, knowledge of basic concepts, science such as physics. The course objective is learn the use of dimensional analysis in physics and engineering fields. So after completion of this course, students will able to know the formula derivation using dimensional analysis. So these are considered to be as a corresponding course outcome. Before starting to discuss about the today's class topic, I would like to remind you that in last class what we have discussed about the details of dimensions. Okay, those who have missed this class, please go through that video once again to understand today's class very easily. Okay, so it will be very helpful for you to understand today's class. What is dimension that I have discussed? That is, the dimension of the physical quantity is defined as the power to which the fundamental quantities are raised in order to represent that quantity. So the 7 fundamental quantities are enclosed in a square bracket to represent its dimension. So basically, each and every physical quantity can be represented by the 7 most fundamental physical quantities. So corresponding units are also represented by the unit of these 7 fundamental units. Okay, so as you know that dimension of these 7 fundamental quantities, as we have discussed in the last class, so the combination of these dimension of these physical 7 fundamental quantities will give you the dimension of the any physical quantity that you want to figure out. So as we know, dimension must be represented within a square bracket. Okay, the mass, the corresponding dimension is capital M. Length, the corresponding dimension is capital L within the square bracket, and the time, that is second unit, is so capital T is the corresponding dimension within square bracket. There is also some other dimensions, say as per that luminous intensity is CD within square bracket, ampere is A, the Kelvin, the unit of temperature, that is K within square bracket, and so on. So the most needed three are mass M, length L, and the time T. Okay, so you can represent any physical quantity by these three: mass, length, and time, represented by these 3 dimensions. So in today's class, we will going to derive the equation of this any physical quantity or some relation by the dimensional analysis after knowing the applications of these dimensions. So I will explain in details step by step. So the first one, that is applications of dimensional analysis. So the method of studying a physical phenomena on the basis of dimensions is called dimensional analysis. So there are 3 main use of these dimensional analysis: to convert a physical quantity from one system of unit to other. Second one, to check the correctness of a physical relation. To derive a relationship between different physical quantities. So the first point, that to convert a physical quantity from one system of unit to another. In first class I have discussed about system of units. So in that class I have discussed that three types of systems that we may use, that is CGS, SI, and FPS. So in most cases we are basically use the SI unit, and in some cases CGS unit also. So physical quantities and its units, say if it is given in SI unit and you are asked to find out what is the corresponding unit or dimension of that physical quantity in CGS system, so you need to know what are the corresponding dimension and corresponding relation between these dimensional analysis, so that you can easily convert the SI unit to a CGS unit. So I will show you in details with some example how you can convert from one system of unit to another system of unit. So this is one application. Second one, to check the correctness of a given physical relation. Okay, so a relation may be given to you, any physical relation between any physical quantity, and you have to check whether that equation is correct or not by these dimensional analysis. So this is the second applications of dimensional analysis. And the last one, to derive a relationship between different physical quantities. You know that say actual relation, actual expression you may not be know, it may be unknown to you, but if some relation between single physical quantity with another physical quantity is given to you, so by using the dimensional analysis you can easily find out, you can easily relate these physical quantity with some expression. So this is the third applications of dimensional analysis, and you can use this dimensional analysis only the basis of the benefits of that dimensional analysis that I have discussed. So I would like to remind you that what are the benefits, that describing dimensions help in understanding the relation between physical quantities and its dependence on base or the fundamental quantities. That is how dimensions of a body rely on mass, time, length, temperature, etc. Dimensions are used in dimensional analysis, where we use them to convert and interchange the unit. Dimensions are used in predicting the unknown formula by just studying how a certain body depends on base quantities and up to which extent. So it makes measurement and study of physical quantity easier. We are able to identify or observe a quantity just because of its dimensions, okay? And the dimensions define objects and their existence also. So by these benefits you can use dimensional analysis for these three purposes. So the first one, conversion of one system of unit to another. To convert a physical quantity from one system of unit to another, it is based on the fact that the magnitude of a physical quantity remains the same, whatever may be the system of unit. Say, let us consider if U1 and U2 are the unit of measurement of a physical quantity capital Q, and N1 and N2 are the corresponding numerical values, then Q can be written as Q equals to N1 U1 equals to N2 U2. So let capital M1, capital L1 and capital T1 be the sizes of fundamental units of mass, length and time in one dimension system. So and M2, L2, T2 be the corresponding units in another system. So if the dimensional formula of quantity capital Q be M to the power small a, L to the power small b and T to the power small c, then you can write the small u1 equals to capital M1 to the power a, capital L1 to the power small b and capital T1 to the power small c. And also small u2 equals to M2 to the power small a, capital L2 to the power small b, capital T2 to the power small c. Now if we substitute the value of u1 and u2 in the first expression, so what we get small l n1 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to the power c, that's equals to n2 within square bracket m1 to the power a, l1 to the power b, t1 to m2 to the power a, l2 to the power b, and t2 to the power c. Now rearranging, we can write small n2 equals to n1 into a within square bracket m1 by m2 whole to the power a, within square bracket l1 by l2 whole to the power b, and within square bracket t1 by t2 whole to the power c. So this equation can be used to find the numerical value in the second or the new system of units. So this actually gives you the relation between two system of units. So if you substitute the value of one system of unit as here m1, l1 and t1, and also the value in the second system of unit, that is m2, l2 and t2, so you will get the new units in the second system. Now I will show you with some example so that it will be very easier for you to understand how you will convert from one system of unit to another. So here the first example is let us convert 1 joule into arc. So joule is a system of unit that is in SI and arc that is CGS. So you have to convert the SI unit to a CGS unit. That is our question. Okay. So dimensional formula of the joule, that means energy, that can be written as m L to the power 2 t to the power minus 2. So if we consider this with m to the power a, l to the power b, and t to the power c, so from here you can write small a, that value is equals to 1, b value, that value is equals to 2, and c value, that value equals to minus 2. So as we know that in SI unit the mass m1 is 1 kg, that means 1000 gram, L1 is 1 meter, so it is 100 centimeter, and T1 is 1 second, and N1 is 1 joule as it is given here. So in CGS, the M2, the mass, that value is 1 gram, the length L2, that is 1 centimeter, and T2, that is 1 second. So as you know, the formula between these two systems of unit to convert from one system of unit to another is small n2 equals to n1 within square bracket m1 by m2 whole to the power small a, within square bracket l1 by l2 whole to the power small b, and t1 by t2 whole to the power small c. So now if you substitute the value of m1, m2, l1, l2 and t1, t2, what you will get? You will get 1 into 1000 by 1 whole to the power 1, 100 by 1 whole to the power 2, and 1 by 1 whole to the power minus 2. So ultimately what you will get, that's equals to 10 to the power 7. So you can write that n2 value is 1 joule, so 1 joule is equals to 10 to the power 7 R. So by this way you can convert from one unit to another system of unit using dimensional analysis. Now the second example is here. The value of capital G in CGS system is 6.67 10 to the power minus 8. So 9 centimeter square per gram square. So calculate the value in SI unit. So as you know, the relation between this capital G is that it is a gravitational constant. So gravitational force equals to F equals to G m1 m2 by r square. So from there you can write capital G is F r square by m1 m2, where F is the force. So if you substitute the dimension of force, that is m l t to the power minus 2 l2 divided by m into m. So ultimately you will get m to the power minus 1 l cube t to the power minus 2. So here again the power compared with m to the power a, l to the power b, t to the power c, you will get a value is minus 1, b value is 3, and c value is minus 2. So as you know, in CGS unit the value of n1, that is 6.67 10 to the power minus 8, m1 is 1 gram, L1 is 1 centimeter, T1 is 1 second. N2 value that you are asked to find out. Capital M2 is 1 kg is 1000 gram, L2 is 1 meter, that is 100 centimeter, and T2 is 1 second. So again, using that same formula, what you will get that N2 equals to N1 into M1 by M2 whole to the power A, L1 by L2 whole to the power B, and T1 by T2 whole to the power C. So if you substituting the value of M1, M2, L1, L2, T1, T2, you will get that value is N2 value is equals to 6.67 10 to the power minus 11. So here, hence the SI unit, the value of capital G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So by this process you can convert from CGS unit to SI unit also. Here another problem is there, that is find the value of 60 joule per minute on a system that has 100 gram, 100 centimeter and 1 minute as the base unit. So here by the similar process, you know power, that is equals to 60 joule per minute. So that means 60 joule per 60 second, that is equals to 1 watt. So which is the SI unit of power. So power, that's equals to the dimension of the power can be written as m L to the power 2 T to the power minus 3. So here again you consider with m to the power A, L to the power B, T to the power C, so give you A equals to 1, B equals to 2, C equals to minus 3. So again the same process, that you just substitute the value of M1, M2, L1, L2, T1, T2 in the formula as per your SI unit and the new system of unit that is given here. As it is given in new system of unit, M2 value is 100 gram, L2 value is 100 centimeter and T2 value is 1 minute, that is 60 seconds. So if you substitute all these value, you will get N2 value equals to 2.16 10 to the power 6. So 60 joule per minute, that value is equals to 2.16 10 to the power minus 10 to the power 6 as per your new system of unit. Now another most important principle, that is also the use of the dimensional analysis, that is principle of dimensional homogeneity. So this principle of dimensional homogeneity states that the dimension of each terms of a dimensional equation on the both sides must be same. So using this principle, the given equation will have the same dimensions on both sides. So for an example, if you consider the example, the equation that is S equals to ut plus half at square, here the dimensions of the both side that you have to find out. Say in the left hand side, that is displacement or distance S, the dimension is L. Okay, in right hand side try to find out what is the dimension. So for the first term ut, velocity into time, so the velocity having a dimension L, T to the power minus 1, time, that is T. So ultimately T will cancel out and you will get the first term having dimension capital L only. The second term, that is half at square. A is the acceleration having the dimension L T to the power minus 2 and T square, so it is a T to the power 2. So again TT will cancel out, you will get the dimension is of the second term is only L within a square bracket. So what you will find out, adding these two will give you a left hand side dimension is L and also the right hand side dimension is L. So it proves the principle of dimensional homogeneity, that means the equation is correct. So another example, check the correctness of equation Fs equals to half mv square minus half u square, where F is the force acting on a body of mass m and S is the distance moved by the body when its velocity changes from u to v. Now Fs, so F has a dimension m Lt to the power minus 2, S has a dimension distance, that is L only, so that will give you ml square t to the power minus 2. Now the first term of the right hand side, that is half mv square, m has a dimension capital M, v square lt to the power minus 1 whole square. So ultimately you will get the dimension of the first quantity of the right hand side is ml square t to the power minus 2. So the second term, it is half mu square, so it also gives you the same dimension ml square t to the power minus 2. So since the dimension of all the terms in the given equation are same, hence the given equation is dimensionally correct. Next question, that is find the dimensions of a by b in this equation. So here the equation is given f equals to a root x plus bt square, where f is the force, x is the distance, t is the time. So the solution is given as that with the square bracket a root x, that's equals to f. Okay, because as per the principle of dimensional homogeneity, the dimension of the both sides that must be same. So from here you can write small a equals to a by under root x as per dimension. So put the dimension of f, that is mlt to the power minus 2, and under root x is l to the power half. So that gives you the value of small a. The dimension of small a is ml to the power half t to the power minus 2. Similarly, the bt square, that dimension is equals to the dimension of force. So from there, small b, the dimension of small b is equals to the dimension of force divided by dimension of t square. So mlt to the power minus 2 by t square, that gives you mlt to the power minus 4. So a by b, the dimension of a by b is ml to the power half t to the power minus 2 divided by ml t to the power minus 4, ultimately l to the power minus half t square. So similarly, another example is here given for your practice. It is find out the dimension of a cross b in the relation. So by the same process you can solve this equation. Now the last application, that is dimensional formula of a physical quantity. So the expression which shows how and which of the fundamental quantities represent the dimension of a physical quantity is called dimensional formula of that physical quantity. So if you know some relation between 2 or 3 physical quantity, by using the dimensional analysis you can easily find out the relation between them. I will show you with some example. That is, here let us derive an expression for the centripetal force F acting on a particle of mass m moving with the velocity v in a circle of radius r. So you are asked to find out what is the relation using dimensional analysis. So first of all, the procedure is you just simply you consider that f is directly proportional to m to the power a, b to the power b, and r to the power c. Okay, so if you write in terms of some equality, so f is equals to k is a proportionality constant, m to the power a, v to the power b, and r to the power c. So r is a dimensionless constant. Now the procedure is you have to substitute the dimension of the both side of this equation. Okay, in the left hand side, as it is a force, so the dimension of force is mlt to the power minus 2 within square bracket. In right hand side it is m to the power a, so mass capital M whole to the power a within square bracket. Next one is velocity, that is lt to the power minus 1 within square bracket whole to the power b, and last one is r, that is distance, so l whole to the power c. So if you combine, you will get m to the power in the left hand side m l to the power 1 t to the power minus 2, that's equals to m to the power a, l to the power b plus c, t to the power minus b. Now if you compare the power of the m, l and t from the both side, you will get a value is equals to 1, b plus c value is equals to 1, and minus 2 equals to minus b, that means b is equals to 2. So calculating, you can easily find out the value of a is equals to 1, b equals to 2, and c equals to minus 1. So if you substitute the power in the first expression, you will get that f equals to kmv square by r. So this is the expression or relation between centripetal force with the other quantities. Now the second example, where consider a simple pendulum having a bob attached to a string and that oscillates under the action of a force of gravity. Here that is the time period of the pendulum is depending on the mass, the length of the pendulum, and the acceleration due to gravity. You are asked to find out the relation. So simply you just write T is proportional to m to the power a, L to the power b, and g to the power c. So similarly you substitute the dimension of t, that means time means second, that is capital T. In right hand side m to the power a, that means mass, capital M to the power a. Length L to the power b, that means capital L to the power b, and last one is g, that is acceleration, that is L to the power minus 2 whole to the power c. So combining this you will get m to the power 0, L to the power 0, t to the power 1 in left hand side, that's equals to m to the power a, L to the power b plus c, t to the power minus 2. So now comparing the power of m, L and t will give you a value is 0, b value that is half, and c value is minus half. So if you substitute you will get t equals to 2 pi root over L by g. So this is the relation. Here another example, that is escape velocity v of a body depends upon the acceleration due to the gravity of the planet and the radius of the planet capital R. So how can you find out the relation? You just put v equals to k g to the power a capital R to the power b, and then substitute the dimension. So in left hand side it is L t to the power minus 1, in right hand side it is L t to the power minus 2 whole to the power a and L whole to the power b. So that means equals to L to the power a plus b, t to the power minus 2a. So comparing the power of both sides, you will get a value is equals to half and b value is also half. So that gives you v equals to k g to the power half r to the power half. That means v equals to k under root g r. That is the expression of escape velocity. So these are the reference books that you may consider. The evaluation process are same. You have to appear for a 70 marks end semester exam and 20 marks mid semester exam, and also a 10 marks for your attendance, assignment and interaction. Hope all of you have understand and enjoyed today's class. So I have covered the topic dimension. In next day I will discuss about the error. So thank you.